welcome back. This is lesson 11.1 journal. We're talking about three-dimensional figures and nets. I will be able to correctly identify solid figures, their bases, and draw a net to represent the figure. I will also be able to identify solid figures from their nets. Okay, we have a lot of vocabulary for this, so please pull out your vocabulary page on page 148. Okay, the chapter 11 vocabulary. Okay, a solid figure is a three-dimensional figure or three-dimensional object. So we're talking about something that has length, width, and height. Okay, the base of a solid figure is the basic shape of a solid figure. The surface is the outside layer of an object. Surface itself is two-dimensional. It doesn't have any thickness when we're talking about the surface. A face is any of the individual flat surfaces on a solid figure. So if I'm using this box as an example, okay, this is three-dimensional. The surface would be like the box itself, nothing on the inside. A face would be this rectangle right here. It's a flat surface. That's one of the faces. This box has 6 faces. There's the top, the bottom, the left, the right, and the front and the back. Okay, an edge is a line segment where two faces meet. So on this box again, this is a face and this is a face. This is the edge where the two faces meet. A vertex is a point where two or more segments meet. Two or more line segments meet. So looking at this right here would be a vertex. We've got this line segment that meets, this one, and this one. Okay, there's a vertex. A lateral face is any face that is not the base. Lateral face is any face that is not the base itself. All right, a prism. A prism is a solid figure with two bases. So each base is the same exact shape. And size, so they're congruent. With two congruent bases is probably what I should have said. And rectangular lateral faces. So if we look at this, the base shape, what is the basic shape of this? The basic shape is a rectangle. So this has a rectangle for a base. Base does not mean bottom. This and this could be the base, this and this could be the base, since they're all rectangles. It actually doesn't matter which one you call the base, but if I look at every other side, see how they're all rectangles? So this is a rectangular prism. Now this, the basic shape of this one, would be a triangle. See how we have 1, 2 congruent triangles? Those are our bases. And then the other sides are all rectangles. So this would be a triangular prism. All right, the basic shape of this one is a trapezoid. We have a trapezoid here and a matching base on this opposite end. And all the other faces are rectangles. So the basic shape is a trapezoid. So this would be a trapezoidal prism. Okay, now another kind that we're going to deal with is a pyramid. And most of you are familiar with pyramids, think you Egypt. However, there are different kinds of pyramids. So a pyramid is a solid figure with one base. This is what's different about a pyramid to a prism. It has one base and what type of lateral sides. So the base of this is a rectangle. The base of this is a rectangle. But do you see how all the other sides are triangles and it meets at a common point? So it has triangular lateral faces that meet at a common vertex. So all those triangles meet right here at this vertex. So the base shape of this one is a rectangle. So this would be a rectangular pyramid. Okay, base does not always mean bottom. I could balance this on its tip and it would still be a pyramid. But the base shape of this one has 1, 2, 3, 4, 5, 6 sides. So the base shape here is a hexagon. So that's going to make this a hexagonal pyramid. Okay, what's the base shape of this? We have this common vertex and it has a triangle for the base. Now because this is all triangles, it probably doesn't matter which one we call the base, but bottom usually is it because that's the one you'd set it down on and the top tip would be at the top. So the base shape is a triangle. So this would be a triangular pyramid. All right, turn your page over. We've got just one more definition we need to do. All right, the last definition is a net. A net is a pattern that you can cut out, or let's say flatten out, and put together to create a model of a three-dimensional figure. Maybe cut would be a better word here. The net itself is two-dimensional. Sorry, flatten was not a good choice there. Cut out and put together. So, this is considered a net. See how it is two-dimensional, it's flat. But if I were to cut it out and fold it together, I could create a three-dimensional figure. So this is where you have to know your bases and your lateral faces and how this would fold together. If I cut this out, looks like I have a base shape of a square. And then if I were to fold these all together so that all edges were touching, this would make a pyramid because all of these points would go together. So this would be a net for a square pyramid. I can identify that because it has one base and then it has four triangular lateral faces. Okay, let's look at this one. Looks like we have two shapes the same. And 1, 2, 3 rectangles. Well, what has a bunch of rectangular lateral faces? That would be a prism, so that would mean that these triangles would be our base. If I were to fold this together, this would make a triangular prism. If I were to cut these all out, they're all squares. And there's 1, 2, 3, 4, 5, 6 of them. So what has 6 squares? If I were to fold this all together, it could be a square prism, or a cube is another word for a square prism. Alright, now that you know these definitions, let's go back to our lesson. And yes, it takes 2 pages, but they're big because you're going to have to do some drawing. So, we're going to talk about all those things that we mentioned. We're going to look at a 3-dimensional figure. We're going to tell how many faces, edges, and vertices we have. And then we're going to draw a net to match it. So, faces on a cube. We have a top, bottom, left, right, front, and back. So that gives us 6 faces. How many edges do we have? Well, everywhere these meet. So I got 1, 2, 3, 4 on the top, 4 more on the bottom, so that's 8, 9, 10, 11, 12. So there are 12 edges on a cube. Okay, vertices are the corners where those edges meet. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. Vertices is just multiple for vertex. So if we're going to draw a net for this, I'm going to need 6 faces. All the faces are squares, and they need to fold together to create a cube. So if I start with the bottom one, I want you to label. That way you know where you're putting everything. So there's a top, a bottom, a left, a right, and a front, and a back. So if this one's going to be the bottom, and I cut down these sides, then the front's going to be attached to the bottom. So I'm going to put F for front. The back is going to be attached to this side. I'm not doing B because there's 2 B's, so front, back, bottom. We've got the left side. We've got the right side. Now, will that cover all of our sides? It will not. So we've got the right, but that's only 5. We have 6 faces. Where's the next one? Okay, the top. What's the top attached to? Well, if I cut it out, I can attach it to any of these. So it doesn't matter where, as long as it's attached, because when you fold it back together, all of these edges are going to come back and connect to it. So I'm going to put the top on that one. There is an example of a net for a cube. Alright, let's try the net for this pyramid. My copy's not very clear, but right here, there's a square on the bottom there. So how many faces does this one have? We have a bottom, and we have 1, 2, 3, 4 rectangular faces, so that would be a total of 5. How many edges do we have? 1, 2, 3, 4 along the base, 5, 6, 7, 8. We would have 8 faces. And how many vertices would we have? 1, 2, 3, 4 where they meet the base, and the 1 where they meet at the top. 5 vertices on this figure. Now how can we draw a net for this? So I want you to think about it. We're going to label it as we go so we don't miss anything. The base is going to be the easiest one. Let's draw a triangle, or a square. So there's our bottom. And then it looks like I have 1, 2, 3, 4 triangles attached to that base. So I'm going to draw this one. This would be the front. I'm going to have one that came off this side. That would be the left side. I'm going to have one that comes off the back. Just going to put B for back since I've already labeled the bottom. And then one that comes off this side for the right. I don't see anything else, because all of those would come up and meet at this point. So that would be a net for my pyramid. Okay, we have a triangular prism here. Let's see. We have 1, 2 bases and 1, 2, 3 lateral sides. So that would give us a total of 5 faces. How many edges do we have? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that gives me 9 edges. And then how many vertices? 1, 2, 3, 4, 5, 6. There are 6 vertices on this triangular prism. Now if we're going to label this, the bottom to me looks like a rectangle, so I'm going to draw a rectangle. I always draw it in the perspective of what I can see and label, that way I don't miss anything. So I got bottom, which is a rectangle. This looks like the front to me, but it's connected to the short side, so I'm going to write it right over here. So I got a triangle for the front. I'm going to call that the front so I can keep my thing straight. My back side is also a triangle, so I'm going to put B for back. Now what else do we have? We have the side on the left, which is a rectangle, so I need to write it off. If this is the front and this is the back, this would be the left side. And then off the base, I also have a right side. There's all 5 faces, all the shapes that I can see. So that would be a net for a triangular prism. Okay, a rectangular prism. I see 1, 2, 3, 4, 5, 6 faces, top, bottom, left, right, front, back. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. And how many vertices? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices on this. Okay, if I'm going to draw a net for this, then that means I want my bottom, which looks like a wider rectangle. Now think about the perspective that you're looking at. This is going to be my front, so this looks like a little skinnier of a rectangle. The back's the same exact size. I have the left side. I have the right side. Okay, I need 6 faces. I only have 5 drawn. What am I missing? The top one. The top's the exact same as the bottom, so I can attach it to either the back or the front, either way. That's between the bottom and the top. So that would be the top. Now I have every side accounted for. I like to name them so that I don't miss something. And if I were to fold that back together, it would make this figure. Alright, let's go to the next page. It says, name each figure based on the net below. So let's look at our base shape. The base shape here looks like I have 4 triangles. So that would make my base shape the rectangle. How many bases? There's only 1 base. So my lateral face shapes are triangles. And there are 1, 2, 3, 4 of those. So what shape has 1 base and triangular face, lateral faces? That would be a rectangular pyramid, because all of those are going to meet together at a point in triangular lateral faces. Alright, this next one, what's my base shape? Okay, it looks like I have 2 of the exact same triangle here, and these aren't all the same. Those are rectangles, so it looks like I have 2, oh, I wrote that wrong, 2, what shape are they? Triangles. And it looks like I have 3 lateral faces, which are rectangles. So 2 triangle bases means that it's going to be a triangular, and then what has rectangles for lateral faces, that would be a prism. Okay, let's look at this next one. I see a bunch of rectangles and 2 trapezoids. So 2 trapezoids, they're congruent to each other. That means that's got to be my base. I've got 2 trapezoidal bases. And we have rectangular lateral faces. Rectangles. There are 4 of those. So this would be a trapezoidal prism. Okay, let's look at this one. Looks like we got a bunch of triangles and 1 pentagon. So that pentagon's probably the base. See how these all come to one point? That gives me a hint this is probably a pyramid. So we have 1 pentagon, and we have 1, 2, 3, 4, 5 triangular lateral faces. So that would make this a pentagonal pyramid. Alright, rate yourself on this concept. How do you feel about making a net or identifying a figure from a net? Rate yourself 0, 1, 2, 3, or 4. Take pictures and turn it in on Google Classroom.